This video, we will try to learn how to plot the vertical velocity of one of the segments in the string or the rope. So let me get to a screen share. In particular here, I'm looking at this segment here, the very center segment. What I want to do is I want to be able to analyze the vertical velocity of that sphere over time. We saw it go up and then back down. So let me get my annotations out. Let's clear all those. And let's get into the code and do this. Okay, so hopefully you've already got this code. If you followed the video for the pause button, that's great. Hopefully that works. I guess I should verify this actually works. Notice the pause button is kind of, sorry, my screen, it's down here. So let's, yeah, so because I've got it zoomed in, there it is. All right, so our pause button is actually working. All right. So, okay, there's going to be a lot in this video to make this plot, so let's get to it. So first up, I'm going to initialize I'm going to use the sphere at the origin just because that seems kind of fun. So I'm just going to call it VY, and because it's at the origin, I'll stick another subscript on there. Now, you might be saying, why am I doing it? This will save me typing later, right? I'm making a small variable name here that will be easy for me to plot later. We don't have to do this, but I kind of like doing it. Next, I need to tell the computer to draw the plot. So, and let me see here. Let's do, let's give this plot a name. Whoops. We're going to tell the computer to make an empty plot. All right. And so we'll call it a graph. Now there's lots of different parameters we can change in here. So one of them would be the title. And then I'm going to get this lined up here. We could have an X title. X title. We could have a Y title. And those are kind of the bare minimum. We're going to need some commas between those attributes. All right. And so let me get my notes here. Okay, so we could use, whoops, got two screens running, kind of confused. What did I just do? Apologies. Where's my graph? Okay, there we go. All right. So in this case, I'm going to use a single quote here, and I'll put the other single quote. So anything inside of these single quotes will be strings. Um, you might be able to do this with double quotes too sometimes, but whatever. And I want to do V underscore Y underscore 0 versus T. We'll talk about the formatting in a minute. And then this one should be time in seconds on the x-axis. Oh, that's not a string. We better make it a string. Okay. So a string just is text instead of numbers that you could do computations with or variables that you could do computations with. Whoops, this looks totally wrong. All right, we'll say equals, and then we'll say V, what did I call it? Y0, and that was in units of meters per second. All right, so we got that. Let's just put that down there. All right. So when I run this one, let's just see what happens here. Do we have anything? Click to proceed. All right. So nothing's going on. We've only created a plot, but we haven't actually made any curves in that plot. So next up, whoops, where did we go here? Sheesh, I lost. Okay, there we go. All right, so now we need to actually draw the curve. So I'll call that a G curve. And then this has some parameters. The only one I'm going to use in this case is the color. And I'm not sure if I've already drawn the ball at the origin. I haven't. So I'm just going to type in the color. This is bad practice here, but whatever. I should probably do things in a slightly different order so that I could reference the ball at the origin's color, but I didn't. So that's fine. And now, okay, so we don't have anything drawn yet. Whoops, that's not milliseconds. Let's just make that meters per second. There we go. All right, so that's looking pretty good. Now, how do I get the velocity of this thing? Let me go into here. What I'm going to do. Sorry, I'm just getting my notes so I don't waste too much time. Let's go into the while loop because that's where the velocity is changing. So this is a whole bunch of cosmetic stuff. Okay, so here's my while loop. So inside of here, what I'm going to do is I'm going to say VY0. Whoops. Actually, let me do a quick annotation just so this makes sense. VY0 should equal Y0 initial, what final, minus Y0 initial all over the change in time, right? Delta Y over delta T. That's how I could get the velocity. Now, the trick here is the velocity is going to keep changing. So I want to figure out the final position and the initial position over and over and over again, which means it needs to be inside the loop. So what I'm going to do is I'm going to say initial vertical position equals, let's see, I want to get one particular position. I'm going to write this in pseudocode here. That's really what I want to get. I want to get the ball at the origin and clip off its y coordinate. Well, how do I get the ball at the origin? The idea is I need to pick out the one at the origin. So I need to go into the rope and pick out the number that's associated with the one at the origin. So a cool trick that we should be able to do is it should be exactly halfway between the two endpoints, right? Because we've made this exactly symmetric. So I'm going to go back and see what I called this thing. N total is the number of spheres. So if I did this right, I believe we could just take this, right? Now, you could do this in other ways in other codes. So this is going to be different in every single code you do. You're going to have to figure out, you could stick in if statements earlier and track this and find out which value corresponds to the sphere at the origin, or you could pick a special one or whatever. But this should hopefully pick off the sphere at the origin. Oh, and I screwed up here a little bit. It doesn't know what dot y is, but it does know what dot pos dot y is. So what will this do? It will say the initial vertical position. It'll go into the rope and look for the one that's in the middle, right? There's n total spheres in the rope. It's going to divide that by 2, so it'll pick off the one that's in the very middle of the rope, which should be at the origin, and it'll look for its position and then trim off the y coordinates of its position. This is important because this will end up being a scalar quantity. And you can't graph a vector quantity. We can graph a scalar quantity. So we're getting just that. Now, take a guess what I'm going to do. This was the initial position. This will be the final position. Now we've got to get our indents right. That would be out of the loop. That's not what we want. This would be in the loop, but not in the for loop. That's what we want. So let's change this to final. And the idea is this records the position before you change it. This records the position after you change it. And so now, hopefully, we could use this equation here. We could say Vy0 equals final vertical, position minus initial vertical position. And then divide that by dt. Now, that's great. And what's going to happen here is I think I can get rid of these animations now. So hold on. Let's get rid of that. The idea now is each time you go through this iteration of the loop, the first time through, it's going to check this condition. It's true. It's going to write down the initial position, and then it's going to change the position of every single sphere in the rope, and it's going to get the final position of that one sphere only, and then it's going to calculate this velocity. Remember, this was initially set to 0, so then it's going to change this number, and now we want to put it in the graph. To do that, remember, we created a curve earlier called Vy0 curve. All right. So in this case, we're going to plot that, and this is how you do that. You put what's on the x-axis, that's the value of time at this step in the loop, and then we're going to put in Vy0, the value of velocity at that point in the loop. And that's it. So, and then what's going to happen is the time will increment. This position is now going to be a different value. In fact, it will actually equal this, the final from before. So what happens is every time the initial gets reset to the new value, you update the positions, and then you get the final position. You do this little difference, and then you repeat this process. So let's run this again. And I'm going to actually make this shorter, and I'm going to zoom in a little bit. So to zoom in, I'm hitting Control and using the scroll wheel on my mouse. You could also double click both mouse buttons to zoom in. All right. And then I'm going to click to start this, and notice we get this graph. All right. Does this make sense? In this case, as the pulse travels, the sphere initially goes up, and then it goes down, and then it stops moving. So this kind of makes sense. But now look at some of the formatting here. It looks like trash, right? So let's go in here and edit this program. And so let's go ahead and fix some of this formatting. So what we could do is we could stick in italics on the variables, not the subscripts that have numbers. See if I remember this right. And then we could stick in subscripts. Hope I'm using the right bracket here. I'm going to just double check so I'm not wasting your time. Where is this on my other code here? That looks right. Did I use the right slash? I did. Okay. And so we'll do some italics here. Whoops. So this just says start the italics. Then over here that says end the italics. Right. And so we could do that with all of these. And then I'm just going to copy all that junk there. Notice the number in the subscript is not supposed to be italicized. All right. In addition, while we're at it, you could also set x min. Whoops. For this one, you're not supposed to use an underscore. X underscore min was a parameter I told the computer. X min is a parameter of the graph. We could say that starts at 0. Oh, I forgot a comma here. Remember, each time you add a new attribute, you got to have a comma at the end. You could say X max Equals, how about 30? I don't, okay, so in the graph, we don't want that underscore. You could do y min. Uh, I think for this lab, -20 should be all right. We'll find out. And anyways, this will allow you to kind of control the minimum and maximum values of the plot. So when I run this thing now, I'm gonna zoom in, shrink this up. I'm gonna click. And so notice that's setting this value. Y maximum is 20, Y minimum is -20. Notice we went from 0 to 30 seconds. Ooh, it looks like I forgot something down here on my italics. But notice the formatting's a little bit better. So you can go ahead and fix that up. Where was that? Shoot, I've already lost it. Oh, wrong slash. All right, let's try that again. There we go. That fixed that up. So that's it for making the plot. Let's go ahead and stop this video and then